Area and volume relationships. We want to calculate the area of this composite shape. So let's think about what it's made of. At the top here we can see a semicircle. There's another semicircle at the bottom. Then we have a trapezium. Now we could split the trapezium into different shapes, but let's do it as a trapezium. So the area will be the sum of all three shapes that we can see. We can see that the radius of this semicircle will be 3 centimeters. The radius of this one would be 8 centimeters. So if we do the small semicircle, a whole circle would be pi times the radius squared, but of course we only have a semicircle, so we'll divide that by 2. Then we have the large semicircle. That would be pi times its radius squared, but of course it's a semicircle, so we divide by 2. Then let's consider the trapezium. To do a trapezium, we do a half times the sum of the parallel sides. Now the parallel sides are the 16 and the 6. And then we multiply that by the distance between the parallel sides, which we can see is 5. So we can work each of these out. So we just need to calculate. I'm going to make the calculation look exactly like it does here. So I'm going to use a fraction template. And I'm going to do pi times 3 squared, divide that by 2, that's 14.137 and so on. So 14.137 and so on. Then I'm going to need to do that with 8 instead of 3. So I'm just going to go back and edit that 3 there into an 8. 100.530 and so on. And then we need to do the trapezium. So that's going to be 1/2 multiplied by 16 add 6, which is 22. Multiplied by 5, and that gives me 55. So now to get the overall area, we just need to add those up. So we have 55, add 14.137, and then I'm going to add that to the 100.530. Now I know when we saw this number to 3 decimal places it would have rounded to 531. It doesn't matter because I'm going to give a final answer to 1 decimal place, so that won't make any difference to us. And that's 169.7. So 169.7, and it would be in centimeters squared, and I've given that to 1 decimal place. If the shape is the cross-section or end of a prism of length 25 centimeters, calculate the volume. For any prism type structure, the volume is equal to the cross-section area multiplied by the length. Now we already have this as 169.667. I know that figure isn't accurate to 3 decimal places, but it doesn't matter for what we're doing here. Then multiply it by the 25. So all we need to do is that calculation. So let's bring in the calculator and multiply that figure by 25. And I'm going to give this to the nearest whole number, which is why that didn't matter. And that's 4242. So that's 4242. Because these are in centimeters, that will be in centimeters cubed. Remember, it's a volume. And I'm going to indicate that I've given that to the nearest whole number. If the shape is the cross-section or end of a prism of length 25 centimeters, calculate the surface area of the shape. We're going to assume the trapezium is isosceles. Now, as far as the ends are concerned, we know that those are 169.7 centimeters squared, correct to 1 decimal place. And we'll have 2 of those. And using 1 decimal place is fine if I give the final answer to the nearest whole number. Then we've got the surfaces going along the shape. So we've got the 2 ends, we now need it along the shape. So that's the curved surface of a cylinder here, and then there'll be 2 rectangles here and here. But there is a shortcut for doing that. And what we're going to do is work out the perimeter of this end shape and then just multiply it by the length. And that will give us the surface area of the bit that goes along the shape. And then all we need to do is add it to these 2 ends. So, what we've got here is a semicircle, so we want half of the perimeter here, half of the perimeter of this semicircle, and then we need these 2 lengths. Now, we've assumed that the trapezium is isosceles, so if I go down here, this would be 6 centimeters along there, leaving us 10 centimeters. So this must be 5 centimeters, this would be 5 centimeters, and this is a right-angled triangle. So we can use Pythagoras to work out this length here, which we need. So let's just call that x for the moment, and x squared would be equal to 5 squared plus 5 squared. So x squared is equal to 25 plus 25, which is 50. So x is equal to the square root of 50. And let's just leave it like that for the moment. And we know that we've got another one of those just here. So the perimeter is going to be 2 of those, because we'll walk along there and walk along here when we're walking around. Then we've got this semicircle. Remember, the radius is 3. So the whole circumference of that circle would be 2 times pi times 3. But remember that we only have a semicircle, and those 2's would cancel, but let's not worry about that. Down here we know that the radius is 8. So that's going to be 2 times pi times 8 over 2. So we've added everything in that we need, and we just need to calculate. So we're going to calculate that. So that's going to be 2 multiplied by the square root of 50. Then we're going to add, well, we said those 2's would cancel, so we can just have pi times 3. And then in the same way we'll have pi times 8. So that's 158.42 if we go to 2 decimal places. So 158.42, and that, remember, would be centimeters. It's just the length, the perimeter. So our surface area we can now get by doing 169.7 multiplied by 2, so that would give us the two ends, and then we'll do this perimeter and multiply it by the length of the shape. So we just need to calculate that. So we've already got this number in here. Let's just multiply that by 25 and then add 169.7, multiply that by 2, and we'll give this to the nearest whole number, which is 4,300. So that will be 4,300 centimeters squared, correct to the nearest whole number. The diagram shows a circle with a square cut out. Calculate the blue shaded area. We can see the diameter of the circle is 20. That means that the radius will be 10. So the blue shaded area is going to be the area of the circle, take away the area of the square. So that's going to be pi times 10 squared, pi times the radius squared for the circle, take away 10 squared, which is the area of the square. So we just need to calculate that. So that's going to be pi times 10 squared, take away 10 squared, and that's 214.159, and so on. So 214.159 and so on, and let's just give that as 214.2 centimeters squared, correct to one decimal place. None of the questions so far have actually given us a specified number of decimal places. A question that you have might, and just be aware of that. The diagram shows the end of a cylinder that has a square hole cut right through it. The cylinder is 15 centimeters in height. Calculate the volume of the material needed to make the solid. Well, it's just going to be a prism. Cross-sectional area times the height. If you think about making the entire cylinder and then cutting out the rectangular prism from the middle, we can do that by just using the blue shaded area and then just multiplying it by the height. So that's what we're going to do. So the volume is going to be the cross-section area multiplied by the length of the shape. So we have 214.159 and so on as the cross-section area, the area of the blue bit, and we know the height of the cylinder is 15. So all we need to do is that calculation, and we've already got this on there, so multiply by 15. And let's give this to the nearest whole number, 3212. So that's going to be 3212 centimeters cubed, correct to the nearest whole number. The diagram shows the end of a cylinder that has a square hole cut right through it. The cylinder is 15 centimeters in height. Calculate the total surface area of the solid. So that's everything that we would paint if we were painting the shape. So we'd definitely paint the blue area here, and there'd be one of those at the other end. So that's going to be 214.159 and so on centimeters squared, and we know we've got that at each end. Now, if we work out the perimeter, in this case circumference because that's a circle, here, that would multiply it by the length, that will give us the curved surface of the cylinder. So we're using that trick about the perimeter times the length. But we'd also paint the inside here. So if we do this perimeter as well and multiply by the length, we need to paint that. It would be a surface area. So our surface area is going to be, we need the 214.159 and so on, multiply that by 2, so that's the two ends. Then we're going to add the circumference here. Now we know the radius is 10, so the circumference is 2 times pi times the radius, and then we need to multiply that by the height of the shape, and then we're going to add that to the perimeter of the square. So each side is 10, so that's going to be 4 times 10, and multiply that by the height as well. So we already have this on the calculator, so just multiply that by 2, and then we're going to add that to 2 times pi times 10 times 15, and add that to 4 times 10 times 15, and let's get this to the nearest whole number, 1971. 1971, remember it's an area, so that's centimeters squared, and we gave that to the nearest whole number.